Okay, we're going to start notes 3.1b. We're going to graph standard form equations by finding x and y intercepts. So the first thing that we need to understand is what the word form means. What does the word form mean? It's the appearance of it, the way it looks, the organization of it, okay? So if you're at a doctor's office filling out a form, or if you're on the internet filling out a form, like right here we have a membership form, there's organization to it. Your name, first, last, address. So there's organization to it. So the word form simply means how it's organized and how it looks. All right. So the word form means how the equation is organized and how it looks. Now we already know a certain form. It's called function form. Function form is when you have y by itself, okay? So an equation in function form would be something like y equals 2x plus 1. The y is by itself on one side of the equal sign. It's in function form. It's the way that it's organized, okay? So today we're going to be talking about standard form, up here, standard form. And standard form is obviously a different way of organizing the equation. It's different than function form that has y by itself. Standard form actually has both your x value and your y value on the left side of the equal sign, and then there's a number on the right side. Let me clear this up and start making space for this, and let's understand something, that the a, b, and c values, they're just numbers. A is just a number, B is just a number, C is just a number. Okay, so it's really not that confusing. Here's an example of a function form equation. 2x plus 3y equals, let's say, 6. That's a function form, not a function form, a standard form equation right there, where your A value is 2, your B value is 3, and your C value is 6. So we're going to be able to take an equation and change it from standard form to function form, or from function form to standard form. By the way, one more detail about standard form. We do not want fractions or decimals for A, B, or C. A, B, and C are integers, not fractions, not decimals, right? They're integers. So you could have positive or negative numbers, but you don't want decimals or fractions. So keep that in mind. When we start changing equations to standard form, you want to get rid of decimals, you want to get rid of fractions by multiplying everything by the denominator, of course, the way we used to do it. Anyhow, let's continue here. On the title itself, it says that we're going to be graphing standard form equations, ax plus by equals c, by finding x and y intercepts. So we definitely need to know what an intercept is. So to understand that better, let's think about the word intersection. All right, so if somebody says Southwest High School is located at the intersection of Ocotillo and La Boucherie, what does that actually mean? Well, here's a map, and here is La Boucherie, and here's Ocotillo. Boom, they intersect right here. So Southwest High School is at this corner, right? So intersection is talking about where the streets intersect, where they cross, right? Or if you think about an interception in football, right? An interception in football. The ball is going to a certain player. The quarterback throws it to a certain player. So the ball's coming. It's supposed to land in this guy's hands right there. Those are ugly hands, yeah. But anyways, this guy reaches up, intersects the path of the ball, and he intercepts it, right? So I think that'll give us a better understanding of the word intercept. What is an x-intercept? It's where your graph, where your line will cross the x-axis. So again, x-intercept is where your line crosses the x-axis. Likewise, the y-intercept is where your line crosses the y-axis. So let me show you an example. If we take a look at this black line right here, it has an x-intercept of -2, right? X-intercept of -2. Here's the x-axis. Your line crosses the x-axis at -2. Or you could give the exact location as a coordinate. So that coordinate is -2, 0. Okay? The y-intercept is right here. It crosses the y-axis at +4, 0. So let's actually move on to today's notes to get a really good understanding of standard form equations and graphing them with the x and the y-intercept. So here's the page of notes, and we already know what a standard form equation is. As a matter of fact, on your notes, you might as well put a little number sign on top of A, a number sign on top of B, a number sign on top of C. And I do put them as capital A, capital B, capital C, just to help you remember that you want these to be nice numbers. Whether they're positive or negative, you want them to be nice. You don't want fractions, you don't want decimals, okay? And that's what it says down here. A, B, and C are just numbers, but this time no fractions and also no decimals. Okay, so let's practice changing equations into standard form, rewriting the equations in a standard form. Down here, number one, we have obviously a function form equation, has y by itself. I'm ready to use an input-output table and plug in three easy numbers, not 0, 1, and 2, but 0, 3, and 6, or maybe 0, 3, and negative 3. But they're not asking us to graph, they're asking us to rewrite this equation in standard form. And remember, standard form is ax plus capital By equals capital C, no fractions. So the very first thing you probably want to do is to get rid of the fraction, right? You don't want that 2/3. So let's get rid of the fraction by multiplying everything by the denominator. Multiplying everything by 3. We're going to end up with the 3y. The 3's cancel, equals 2x minus 1 times 3 is 3. So we got rid of the fractions. So far, so great. And now, let's take a look back at what we want it to look like, the form, the organization of it. And the organization has the x and the y on the left side of the equal sign. So notice, I have the y on the left side, but I do not have the 2x on the left side. I need to get this 2x and move it over here. So to get rid of the 2x on the right side, I am going to do the opposite of 2x, which is subtracting 2x. 2x take away 2x is 0. What you do to one side, you do to the other side, subtract 2x. And your final standard form equation will be, you can't really do this. You can't subtract different terms, so let's rewrite it. It's going to be negative 2x. Now notice I wrote the x first. I could have written 3y minus 2x, but standard form has your x term first. So let's write negative 2x plus, because it's a positive 3y, equals negative 3. And ladies and gentlemen, that is your standard form equation. Your A value is -1, your B value is 3, your C value is -3. Now let me tell you this, sometimes on certain test generators, it'll pop up as the A value being positive. So let's say you're taking a multiple choice test and you don't see this exact standard form equation for this one. It is possible that they take this whole standard form equation and multiply it by -1, which would technically change all the signs, and it would be a positive 2x, a negative 3y, and equaling a positive 3. So this might be your standard form equation. So for my open response quiz on Friday, either one of these, this one or this one, will be good enough. Let's move on to number 2. Right here we have two different fractions. And again, standard form, you can't have any fractions or decimals. So you want to get rid of all fractions. The way to get rid of both fractions at the same time, we've already done this before when we solved equations and we didn't want fractions. When you want to get rid of fractions, you need to multiply everything by the LCD. That way it'll get rid of all fractions at the same time. Or if not, you could, of course, multiply by 2, it'll cancel, multiply by 2, it will not cancel, and then multiply everything by 3. But if you want to do the faster method, the shortcut, the better method, that would be to take your LCD, which is actually 6, and multiply everything by 6. This times 6, this times 6, this times 6. So we end up with 6y. The 6 over 2 cancels. 6 divided by 2 is 3. And up on top, 3 times 1 is 3. So you have equals 3. And of course, there's an x with the 3. And then over here, 6 divided by 3 is 2. And you really have 2 times 2, which is 4. So we got rid of both fractions at the same time, and now all we have to do is get it in standard form, which means you want your x's and your y's on the left side. So I need to get this 3x and move it over to this side. So I need to get rid of that 3x by subtracting 3x. 3x, take away 3x is 0. What you do to one side, you do to the other side. And all you have to do is rewrite it. So your standard form equation, -3x plus 6y equals 4. That's a great answer. Sometimes they don't want to see a negative a value, so they multiply everything by a negative 1, and it'll be positive 3x negative 6y equals negative 4. Either one of those is 100% correct on the Quiz Friday. Number 3, the LCD right there would be 4. Okay, so let's go LCD is 4. So I multiply everything by 4. I multiply the y times 4, the 7 over 2 times 4, the 1/4 times 4. So right here, 4 times y, that's 4y, equals, now 4 over 2, 4 divided by 2 is 2, and 2 times 7 is 14 with the x. And over here, the 4 over 4 is 1, it cancels out, so you bring down the plus 1. So we have 4y equals 14x plus 1. So to get rid of the x, the 14x, because remember, we want standard form, and standard form has x's and y's on the left side, and the number by itself on the right side. So let's get rid of that 14x by subtracting 14x and subtracting 14x. Now we're going to rewrite it. Negative 14x plus 4y equals 1. And if you want the other method with the, or the other equation with the a value being positive, you just change all the signs. 14x minus 4y equals negative 1. Either one of these is perfectly fine. So now that we know how to rewrite equations in standard form, I guess right now is a good time to end video 1 and start up video 2. Because one skill that you need to be able to do is change it into standard form. The next skill is to be able to use that standard form equation to be able to find your x and y intercepts. So we're going to start the next video with finding x and y intercepts of a standard form equation.